So this is a video demonstration of an emulation of an Enigma machine running on a PIC32 microcontroller. What I have open on my screen is on the left side is a view of the microcontroller on which the emulation is running. It's actually running specifically on this chip. This is a PIC32. Also open on the screen is a Python interface. This is running on the host PC, and this acts purely as a user interface to the emulated Enigma that's on the microcontroller. So through this Python interface, I can send characters into the emulated Enigma machine and view the characters that the Enigma machine sends back out. So this plays the role, if we were to compare this to an actual physical Enigma machine, this plays the role of the keyboard and the lamp board, and all of the other components of the Enigma machine are emulated on the PIC itself. Through this user interface, I can also change the rotor settings, which is the same as it's the software analog of physically rotating the rotors to the proper orientations to start a transmission. So I can change the rotor settings and I can key in entries and then view the output. And then I also just have a couple other things up. A Python interface just to generate some random characters, and a text window to keep track of what I'm doing. So I want to show how this works. Any operator of an Enigma machine, if they wanted to send a message using the Enigma machine, the first thing that they would do is consult their code book. Every Enigma machine operator got a code book, and that code book contained the settings for the Enigma machine for a particular date. So the operator of the Enigma machine would go into the code book, go to today's date, and look up the configurations of the Enigma for that date. And those configurations would include the stecker board configuration. This is also known as the plugboard configuration. The rotor order and settings. Different versions of the Enigma machine had different amounts of rotors inside of them. The version that I'm emulating has 3, but there were more than 3 rotors that could be fit into the machine. So the code book would tell the operator which of the 3 rotors to put into the machine and in which order, and some other settings of those rotors. And then the final thing that the operator would look up is the indicator setting, which is the orientation of the rotors in the machine. The rotors, of course, rotate. So the indicator setting told the operator the orientation to which to rotate them at the start of a message for that particular day. And then they would do some other things, but I'll demonstrate the other things in real time. So some of these settings I have hard-coded in the C code that's running on the PIC, specifically the stecker settings, the plugboard settings, and the rotor settings are hard-coded. And then I can configure the indicator setting through the Python interface. So let's pick some indicator setting. Like I said, this is something that in practice would be looked up in a code book. I'm just going to generate one randomly. So we'll use the indicator setting PDG. So now I'm going to, quote, rotate these rotors to PDG. So now the rotors are in the proper orientation. The next thing that the operator would do would be to pick some random message setting. So this would be up to the operator for each message that they send. It could be chosen at random. I will choose one at random. We'll use KAY. So our message setting is going to be KAY. So the operator, with the Enigma configured to the indicator setting, would key in their chosen message setting. So I'm going to key in KAY. I get QZB out, and the operator would write that down. So I'm just going to write down that we got QZB out. The operator would then set the rotors to their chosen message setting. So we chose the message setting KAY, so we will set the rotors to KAY. And now it's configured to send whatever message you would like. I will send the message hello world. So HELLOWORLD. L L O W O R L D. And this is the enciphered hello world. So the next thing that the operator would do is then send this message. And what they would actually send is the enciphered message setting. So they would send QZB and they would send the ciphertext. On the receiver end, so that message gets sent and then it's received by someone else with an Enigma machine. The receiver would configure, they have the same code book. So the receiver would consult their code book to get the right checkerboard settings, the right rotor order and settings, and the right indicator setting. And they would configure their Enigma machine to the same initial configurations that the sender used. So we used an indicator setting of PDG. So we'll set this to PDG. PDG. And then with the Enigma machine configured, the recipient would then key in the enciphered message setting. So the enciphered message setting was QZB. So we'll key in QZB. And you can see that the output with the Enigma machine configured properly, when you input the ciphertext, you get out the plain text. And in this case, what this plain text represents is the sender's chosen message setting, which was KAY. So now we know the message setting to choose to decipher the rest of the message. So now with the deciphered message setting, we can configure the Enigma machine to the sender's chosen message setting, which was KAY, as we've just learned. So KAY. KAY. So now we have the recipient has the Enigma machine set up with the sender's chosen message setting. And we can now key in the ciphertext, and what should come out is the plain text. So the ciphertext was this is the enciphered version of hello world. If we now key this in, we should get hello world out. So it's EDIYJIMQGL. And we get hello world out.